guys, this is the double lens system, and the question is asking, they want to find the distance between the image here, the object I mean, and the image after after the light's gonna get refracted from this lens and this lens. Okay, so the way to look at it is to first ignore this, like ignore this lens. Okay, so when we ignore it, we're just gonna do the light ray that's gonna refract it on the focal point, and then one's going through the focal point and it's gonna go parallel to the light. Okay, so we know that object gonna produce here. Okay, so let's use the 1 over s plus 1 over s prime equal 1 over f. Okay, so 1 over s, my s is the distance between the object and then the lens, which is 18, so it's 1 over 18 plus 1 over s prime. S prime is the distance going to be from this lens to here. S prime equal 1 over, and then the focal point is 8.5. Okay. Plug in the calculator, we'll get 1 divided by 8.5 minus 1 divided by 18. You'll get this divided by 1. Get 16.105. So S prime 1 will be equal to 16.105. Okay. Okay. So let's get the magnification of this lens. So M will be S prime over S. Let's say S1, S1. So it's going to be 16.105 divided by S1. S1 is 18. So our answer divided by 18, you'll get 0.8943. This is negative. And you can see here that it's inverted, right? Okay. So question number 2. No, we're still at number 1. So now we got the distance from this lens to the image that it produced. Okay. So now this is now going to be the object for the other lens. Okay. So the distance between them, between this object and the image, which is now the object for this lens, okay, is, if the whole thing is 16.105, then between here and here is 16.105 minus 503, right? Okay, so 16.105 minus 5.03, you'll get 11.075. So S2 will be 11.075. Okay. Alright, so let's do the 1 over S. So this was 1 over S2 plus 1 over S2 prime equal 1 over F. And they gave me that my F, because it's a diverge one, it's got to be a negative. They gave me that's 1 over minus, what was mine? 33. And the S1 will be negative because it's to the right of the lens. Okay, I think it's because the same side as the eye is looking. Okay, this is supposed to be an eye. Okay, so 1 over minus 11.075 plus 1 over S2 prime. Okay, So take this to the other side, it'll be negative. So 1 divided by the answer minus 1 divided by 33. So we get 16.66. So S2 prime will be equal to 16.66. Okay. So let's get the magnification for this one. Okay. Alright, so M2 will be equal to 16.66 divided by the no, this is the S2, so we'll divide this. It's true because we're looking at the S prime over S1, so 16.66 divided by the 11.075, and this one is negative, and this equation is also negative, so we'll get a positive number. So 16 divided by 11.075, you get 1.505. So this is the magnification, 0.505. Okay. Alright. So we got the distance S2, right? We got S2, which is the distance between the object, between the image that's produced by the first object, which was now the object for the second lens. So the second lens, the distance between the second lens and this image, or not this image, the image that's going to be produced, and since the magnification is 1.505 and it's positive, so it's going to be the same shape as this one, but it's going to be somewhere here. It's bigger than it, and we know that's on the right side because it was magnified. It was getting bigger. I don't know how to say the other one, and it was positive. Okay, so we have the distance between this one, the new one, and the lens, which is 16.66. So we'll add 16.66 plus the distance between the two lenses, which is 5.03, plus the distance between the object and the first lens, which is 18. Let's see, so 16.66 plus 5.03 plus 18. I get 39.69, okay, centimeters. Okay, so this is the distance between the image that's produced by the two lens system and the first object, or the object, the original object. Okay, so they want the second question. They're asking about the, what's over here? So question number 2, they're asking about the total magnification. So the total is equal to M1 times M2, magnification of this one and magnification of the other one. Okay. So the first one we got minus 8.8943 times the M2. M2 is 1.505. 1.505 times 0.8943. So we got minus 1.345. So you can see here, this is telling us that the object and the final image is inverted, negative, and it's bigger than the first object. Okay. Alright, I hope this helped, guys, and good luck.